So today we have very interesting section and very simple section actually. It is just a formula and we need to know how to apply it. We will derive it together inshallah and then we will see how to apply it. What is a Newton's method or what we call sometimes Newton's Raphson method? It is a method, a numerical method. It is, you know when we have, like a branch in mathematics called numerical analysis. Newton method is one of these methods that can approximate roots or solution of certain equation. For example, we have, if I said, for example, sine x equal to x, if I said sine x equal to x, and I know there is a solution for this equation, I can prove it by intermediate value theorem. But how to find it out? Algebraically, it is not easy, or it is impossible even to find out the root exactly. So as mathematicians, we always look for approximate solutions if we do not have exact solutions. To find approximate solutions, we need some methods. We call them numerical methods. Numerical method to approximate solutions, regardless if the problem is finding roots or finding solution of differential equation or finding solution of integral equation. Any kind of problem in mathematics, if you cannot find out the answer exactly, you always look for kind of approximation for the solution. Now, what is a Newton method? We will try to derive it and then see how to use it. Look for the blue color here, the blue graph here, y equal to f of x. We can easily see that we have a root for the equation. This is the root. This is called the exact root. This is r is the exact root. And we are trying to find this root. How the method works. How the method works. A very simple technique, and we will illustrate it in a minute. The method says, okay, if by chance you know, for example, that there is a root, for example, between this number a and this number b, by the intermediate value theorem, for example, but you don't know how to find out this root. What we will do to find the root, as we said, we have different methods. One of them is called Newton's method. The Newton method says, okay, in that case, what you need to do is choose a point, initial guess, they call it. Choose an initial guess. Here we choose the initial guess x1. Okay. If you choose the initial guess x1, there is a point here. This point is called x1 and f of x1, as you can see in the graph. واضح? Then what we will do, we will draw the tangent line at that point. The tangent line at that point, which is the red line here. I am drawing the tangent line exactly at this point on the graph where we have guessed the first point x1. So x1 should be guessed, call it initial guess. طيب. After we graph this line, let us now find the equation of this line. What is the equation of the red line color here? What is the equation of this? Can you find the equation of the tangent line? Let me say like this, equation of the tangent to y equal to f of x at the point x1 and f of x1. What will be the equation of the tangent line at that point? Clearly, we have what? Y minus y1, يعني y minus f of x1, if you like, is equal to m. What is the slope of this line at that point? By our discussion. Yeah, what do you call it? What is the slope at this point? What is the slope of the tangent line? Yes?
Derivative.
أحسن, the derivative at x1. So that will be what? F prime of x1. That is the slope of the tangent line, multiplied by x minus x1. Now the method says the following. What you need to do is try to find the x-intercept of this line. واضح? So we start with x1. We have a point here, f of x1 and f of x1. We draw a tangent. Then we will find the x-intercept of that tangent. We will call it x2. فايش راح يصير الآن x-intercept? What is the x-intercept? X-intercept implies y equal to what? 0. And this will give us the following. If you put y equal to 0, you have minus f of x1 equal to f prime of x1 multiplied by x minus x1. Solve for x. Solve for x. Find the x-intercept. We need to solve for x. And this implies clearly, if you can see that x minus x1 is equal to what? I will divide by f prime. So what do we have? It will be minus f of x1 divided by what? F prime of x1. And finally, I can find x to be equal to x1 minus, I can write it this way, f of x1 divided by f prime of x1. لاحظوا يا شبابنا, what we did, we found the x-intercept. Now the x-intercept will be called x2. Set x2 to be x1 minus f of x1 over f prime of x1. Let us see x2 in the graph. What does it represent? لاحظوا the graph here. This is the straight line we are talking about. So x2 here stands for the x-intercept of the tangent line at x1. We have an initial guess x1. We find the tangent line at that point. That tangent line will give me an x-intercept. That x-intercept, I will call it x2. وهكذا. Now what I will do next? What I will do next? I will go to the graph at x2 and I will draw a tangent line there. I will draw a tangent line. That tangent line has an intercept. I call it what? x3. لاحظوا what is happening to x1, x2, x3, x1. What's happening here? They are coming closer and closer to what? To the root. يعني الآن I will go to x3. What I will do with the x3, I will go to the graph here. Maybe I need to choose the red one here. I will go to the graph and I will draw a tangent line. And I will take the x-intercept. This will give me x4. I go to x5 and so on. So what's happening here? We are getting better values for the root as we go, more in the, iteration of Newton's method. Okay, so what do we have? What do you expect x3 will be? What will expectation for x3? So, and doing so at x2, we get the following. We will have the following answer. That will give me x3 is equal to x2 minus f of x2 divided by f prime of x2. هذا الأول يسموه الانيشال guess x1. هذه يسموها second approximation in Newton method. This one is called the third approximation in the Newton method. x4 will be x3 minus f of x3 over f prime of x3. Okay, I have...
Doctor,
Yes, please.
I have a question.
Sure.
The x3 is equal to x2 minus f of x2 over f prime of x2.
Yes.
Isn't it going to be zero? X3 equal to x2 because f of x2 is equal to 0.
Who said f of x2 is equal to 0?
We find the intercept.
L of x2 is 0.
Oh,
Yes.
okay.
But not f of x2. F of x2 will be here, isn't it?
Yes, true.
صحيح؟ L of x2 is 0. يعني هي الطريقة سهلة جدا. انت you will start with the initial guess. سميه x1. Then you will go to the graph and you will graph a tangent line. راح تاخذ الانترسبت حقه تسميها x2. راح تيجي للجراف مرة ثانية and you will draw a tangent line here. الانترسبت حقه راح تسميها شنو؟ x3. Then you will go to the graph again and you draw a tangent. The intercept will be called x4. واضحة الآن؟
واضح يعطيك العافية.
Okay, good. In general, what is the formula? In general, what is the formula? Let me just take this one little bit up in order to save space and write it in general. Let me say like this. In general, what will be the formula, what is called the Newton method? In general, this is the formula that will be used. Xn plus 1, the next iteration is equal to xn minus f of xn divided by f prime of xn. This is called Newton method. Newton's method, starting with an initial guess. x1, طبعا this is true for n equal to 1, 2, 3, etc. If you substitute n equal to 1, you have x2 in terms of x1. If you substitute n equal to 2, you have x3 in terms of x2. وهكذا. And this is what we call a Newton method. Is the methodology is clear for you? How it works? We said we know there is a root. So we start with an initial guess. We go to the graph. We draw a tangent line. Then we take its intercept. We call it x2. Again, we go to x2. We go to the graph. We draw a tangent line. We take its x-intercept. We call it x3. And hoping that this procedure will approach the number R we are looking for. This method is called Newton's method. Before we apply it, we will say some words about it. Yani. Maybe it's not too interesting for us in Math 101, but always when you have a numerical method, people are interested to know the following. The first one, is this method really give us a good approximation? Is it convergence, as we say in mathematics? Is it convergence to the real root? That is one thing. The second one, how fast is it? This is very interesting question always in a numerical method. How fast is it? What is what they call the efficiency of the method? How efficient is this method? هذه النقطة الثانية. النقطة الثالثة, when we need to terminate, how to terminate? How do I know I need to stop now? We will answer these questions, inshallah, during the explanation of the section. I will say the first one, this method, which is called the Newton method, depending heavily in building sequence of points, x1, x2, x3, x4, xn, and we hope that these points are approaching. The limit of these points will go to that number R we are looking for. That is the first one. The second one, this method is very sensitive with the initial guess. It is very sensitive with the initial guess in the sense that it may mislead us to the wrong answer. So it is very sensitive to the initial guess, okay? And this may give us totally wrong answer. Okay, to see this point, look for example, let us look for the graph given here. لاحظوا مثلا, this is our root R. This is our root R here. Although we are so close to the root in the initial guess, see what happened in the process which is called the Newton method. ايش راح يصير الآن في الطريقة؟ قلنا when we go to x1, we need to go to the graph and we need to draw this line which is called tangent. And we will take its intercept as the second iteration. So the second point of approximation x2. The question for you now, which one is closer, x1 or x2 to the root?
x1.
X1 is closer to the root R, isn't it? Yeah, this distance here is much smaller than this distance from here. Let us say smaller than the second distance. Okay, maybe this will happen only in the first iteration. Let us see what happened in the second iteration. In the second iteration, x2, I need to go to the graph. I went to the graph here. I draw this tangent line. Then I will take its intercept and call it x3. Now, which one is closer, x2 to the root or x3?
x2.
Sorry,
X2 is closer.
What happened to the sequence we are building? Are they convergent or divergent? Are they going to the real root or it is far away from the real root? Actually, when you do this, by this choice of x2, x1 that leads to x2, x3 is outside the domain of the function. The function is even not defined here. There is no function at all. So yes, this is very bad about the Newton method, but it is working fine in many examples, many questions. It is good method in a sense that it will reach the answer if the sequence is convergent. But in some rare cases like this, it may give you the wrong answer. So in that case, we need to be very, very careful. Is the method is convergent or not convergent? Okay, maybe someone else only will move the guess here. يعني he has an initial guess x1 here. Then you can see he will get a better approximation x2. This is x2 and this is the root. So as I said, it is very sensitive to the initial guess. يعني واحد يكون حظه جميل يعني أفضل من الأول يختارها هنا مثلا. When he draw the tangent line, you can see we are very close to the root. When you go again, we come back, we are very close to the root. مع أن الخيارات بين الx1 هنا وبين الx هنا they are very close. لكن it will give totally different answer. One of them is accurate and the other one is totally wrong. الآن المطلوب عندنا في الفاينل exam شنو في الطريقة هذه؟ The only thing, and this is a gift for you. The only thing needed from you is to know how to apply the method. How to apply the method. A classical question always will be repeated in final. We'll give you a function or an equation, and they will say, for example, starting with x1 equal to 2, he will give you the initial guess for sure in the exam. The question will say, find the third approximation or find the second approximation. In the exam, usually they ask either about the second approximation or the third approximation maximum, not more than this, not more than this. So he said, starting with x1 equal to 2, find the third approximation, x3, to the root of this equation. طبعا, sometimes they mention that you need to use the Newton method. If it is given one iteration, we have only one method works with iterations. So what should we do? First, I need to let f of x, I need to define my function. So this is f of x equal to x cubed minus 2x minus 5. That is our function. In the formula, I need the derivative of this. So what is f prime of x? F prime of x, it will be 3x squared minus what? Minus 2. 3x squared minus 2. Jamil, I have x1, I need to find x2. What should I do? x2 by the formula is equal to x1 minus الآن f of x1 all over f prime of x1. تمام? I apply this one. So what do we have here? x1 is given in the question. It is equal to 2. Minus, now I have f of x1, يعني f of 2. What is f of 2? I substitute here. I have 8 minus 4 minus 5. أحسنت, it will be 8 minus 9, negative 1. So I can write this one minus 1 divided by, now I substitute in the derivative at x1, the derivative at 2. The derivative at 2 will be 2 squared is 4 by 3. I substitute here.
10.
This is 4 by 3 is equal to 12 minus 2, that's equal to 10. Jamil, this is equal to what? It will be 2 plus 1 over 10, which is, if you like, 21 over 10. صحيح? This is what we have. طيب, now, which is 2.1 if you like. يعني you can write this one also as 2.1. Jamil. What about x3? He's asking of x3. Let me see if I left a space or we write it. Yeah, okay, fine. We have enough space here. So what is x3 then? By the formula, x3 is equal to, it is the next second iteration minus f of x2 all over f prime of x2. يعني بمعنى آخر, this is 2.1 minus f of 2.1 as we found in the previous iteration f prime of 2.1. Now you need to help me to find the answer. This is 2.1 minus, let us now go back and substitute in the function 2.1. So 2.1, you can calculate with your calculator, please. Cubed minus 2.1 times 2, that is 4.2 minus 5, يعني minus 9.2. This is minus 9.2. So can anybody find the answer? 2.1 cubed
0.061.
0.061.
0.061.
Okay, let us copy it here. 0.0.061. Okay, now you substitute in the derivative by 2.1. What do you get? يعني you just evaluate 3 times 2.1 all
11.23.
squared minus 2. Yes?
11.23.
Anybody can confirm this answer?
Yes, Doctor. That's right.
Okay, ممتاز.
Yes.
What is that? 11
11.23.
2, 3.
0.23, is it? Like
Yes.
this?
Yes.
طيب. Now
Yes.
let us divide. 0.6 is 0.061. Calculate this one. 2.1 minus 0.061 over 11.23. What is the answer? Final answer.
2.09.
2.09. ممتاز جدا. So,
دكتور
yes, please.
بالفاينل تجينا زي كذا ارقام.
No. In the final exam, they will give you very smooth numbers and you no need for a calculator to find the answer. Very smooth number, simple. The idea is just to test you whether you understand how to use the Newton method or not. I will show you in a minute, inshallah, some examples from final exams. هذا مثال مثلا يقول if we use a Newton method, if we use Newton's method to approximate the solution of the equation, starting with x1 equal to pi over 2. Then the second approximation is simple. This is a final exam question. You can see it is straightforward. يعني if I need to find x2, first I need to find the function. F of x will be equal to, I define it to be 2x minus 3 cosine of x. And directly I will evaluate the derivative of this function, f prime of x. And the derivative will give me 2 minus will be plus 3 sine of x. جميل. الآن I need x2 only. In the final he said what is x2 given x1? That is very simple. x2 will be equal to, according to the definition or according to the formula we derived, which is called the Newton method, x2 is nothing but x1 minus f of x1 divided by f prime of x1. جميل. And this implies x2 will be equal to, what is x1? x1 is given in the question, that is pi over 2. This is pi over 2 minus, now what is f of x1? I substitute f of x1. I substitute pi over 2 in the function f of x. So it will be 2 times pi over 2. That is equal to pi minus a 3 cosine pi over 2, which is 0. So the answer is equal to pi. What about f prime of pi over 2? I substitute here by pi over 2. I have 2 plus 3. That is equal to 5. So the answer will be, final answer will be pi over 2 minus pi over 5. Now, if you combine them in one fraction, this will be 10. And what do we have? I multiply 2 by 5. So I multiply upstairs by 5. So that will be 5 pi. And minus 2 pi, that's equal to what? 3 pi over 10. Do you agree with that?
Yes.
And this is a style of the final. This is exactly a question from final exam. Okay, let us see another question from the final exam. يعني the question says here, using, let me take it a little bit up here because we have enough space. Okay. Okay, let me just do it carefully so that it will not be outside the. Yeah, good. Now the question, as you see, it is a classical repeated all the time. The only thing, functions are changing or the style of the question is changing. راح أذكر لك بعض الطرق اللي ظهر فيها هذا السؤال في الفاينل exam. One of them is already done. Given x1, find x2, we have equation. هاي النوع الثاني يقول if Newton's method is used to estimate, sorry, there is a misword here, is used to estimate the x coordinate. Let me just write it down here. Is used here, is used to estimate the x coordinate of the point of intersection of the curve y equal to radical x and y equal to 1 minus x squared. If we start with x1 equal to 1, then x2 equal to what? Okay. ممكن حتى الاف هذه ما لها داعي. Newton's method is used to approximate, so there is no need for the f here. Newton's method is used to estimate the x coordinate of the point of intersection of the curve y equal to radical x and y equal to 1 minus x squared. If we start with x1 equal to 1, find x2. شو نسوي الآن? How to find intersection point between two graphs? What should we do?
B equals the y's.
We equate them together, صحيح? So what do we have? It will be like this. I need to find the x coordinate of intersection point. يعني I need to solve this equation. هذا معنى the x coordinate of the intersection point between the two graphs. هذا المعنى solving this equation. يعني بمعنى آخر I need to find the solution of this equation. Radical x plus x squared minus 1 equal to 0. Do you agree with this? Now I will take the function, let f of x equal to, I will reorder them, x squared plus radical x minus 1. وهقول طيب لو أخذنا الراديكال x الطرف الآخر صار عندنا شنو؟ 1 minus x squared minus radical x. Is this one also correct or not correct? I can write it this way, I can write it that way. Are both of them correct or not?
Yes.
The answer is yes, both
Yes.
of them are correct. It doesn't make a difference if you take the left-hand side minus the right-hand side or the other way around. It will give you the same answer at the end. Okay? طيب, okay, fine. This is f of x. What is the derivative of this? What is the derivative f prime of x? What is f prime of x? The answer will be, it is 2x plus 1 over 2 root of x. طيب, let us see again if I have, yeah, I have space, good. So now how to find x2 if we have x1? That's the question. How to find x2 if I have x1? I will say here, this implies x2 is equal to, x2 is equal to what? By the formula, it is x1 minus f of x1 divided by f prime of x1. جميل. الآن نعوض هذه. شو يساوي? This is equal. This is equal to x1 is given in the question. It's equal to 1. So I will take it 1 here. Minus, I open the fraction here. F of x1. F of x1 راح أعوض عن ال f of x by, I substitute for x by 1. So I have 1 plus 1 minus 1. That is equal to what? That is equal to 1. So this is equal to 1. Okay, let us substitute now in f prime of 1. F prime of 1 will be 2 plus 1 half, 2.5, 5 over 2. I will take it and substitute here 5 over 2. And this is equal to 1 minus, that will be 2 over 5. So it is 5 over 5 minus 2 over 5. The question answer is 3 over 5. You can see this is another exercise from also final exam. This is an exercise from a final exam, and you can see it is a very simple idea. If you remember the formula, it is piece of cake. You just substitute to find the answer. طيب, قبل ما أروح للسؤال الأخير أذكر فقط من الذاكرة الآن what happened in some finals about the Newton method. One time, only one time, I guess, I remember that they asked the question in this way. They said, if the x-intercept of the tangent line to the graph of f of x, معطاه السؤال, f of x is given, to the graph of f of x, which is given, is this. خلينا نصيغ سؤال، ايش رايكم نصيغ سؤال الان اساس نشوفها بشكل واقعي يعني.
Yes.
اوكي نقول بالشكل هذا، يقول كان السؤال نصا، خلينا نضيفه في المارجن هنا and then I will show you how to. مثلا if the x-intercept، نستعين اللي هو الاشياء اللي عندنا هنا. اوكي تذكروا الداله هذه x سكوير بس هذيك ال x minus 1. اوكي the x-intercept of the tangent line to the graph of هذه الدالة الآن اللي قلناها شنو هي؟ x سكوير radical x plus x سكوير plus radical x minus 1. x سكوير plus radical x minus 1. This is f of x equal to this. Okay, is equal to 1, is equal to 1. What is the x-intercept of sorry this if the x-intercept of the tangent line to the graph of this, the x-intercept of the tangent line to the graph of this at the point at the point at x equal to 1 is equal to, and let us see what happened if we substitute that one. وش أعطانا عند الواحد 3/5 صحيح 3/5. Then find the third approximation for the root of this equation x squared plus radical x minus 1 equal to 0. يعني هو قاعد يختبر الطالب هل هو فعلا فاهم الطريقه يعني the methodology or not. That's the idea. الان نجي للسؤال نقرا فقط، ما راح احل السؤال، فقط نقرا ايش معنى السؤال الان. شو what is given لما يقول لي if the x-intercept of the tangent line to the graph of this function at x equal to 1 is equal to 3/5. يعني هذه ال 3/5 شو تمثل؟
السكند بوينت.
احسنت second approximation. هذا معناها ان x2 equal to 3/5 لان ال x2 معناها شنو؟ it is the x-intercept of the tangent line at the initial guess. اذا كان الانيشال guess هو x equal to 1 ورسمنا خط مستقيم مماس واخذنا الانترسبت حقه، هذا يعطينا x2. فهذه هي الاx2 في الحقيقه. كأن السؤال شنو يعني؟ كأن اعطيني x2 وطالب مني شنو؟ x3 فقط لا غير. يعني باقي خطوه ثانيه نعملها على الخطوه الاولى اللي عملناها. واضحه الصوره ان شاء الله للجميع؟ is this one clear for you؟ هذا الستايل الاول. النوع الثاني وهذا خدعوا فيه تقريبا اكثر من 90% من الطلاب. كان السؤال يقول if x1 equal to 1 مثلا is the first approximation for the critical value of the function f of x given. ان شاء الله كل المسائل هاي راح نحل مثلها في المراجعات ان شاء الله. لما يقول لي x1 is the first approximation of the critical value، بعدين يقول then x2 is equal to what؟ شنو معنى السؤال؟ شنو نطبق يعني الان نيوتن method؟ If a Newton method is used to approximate the critical values of the function given, then x2 equal to. يعني خلينا نعطي المثال f of x مثلا مثلا let us say sin x minus x. This is the function.
ناخذ derivative حقها.
اخذنا الديريفيتيف حقها. طيب f prime of x شو يساوي؟
ونستخدم
cosine
قانون
x طبعا ما نبغى هاي يصير ماينس، خلينا نقول اكس سكويرد ماينس 2 اكس. الان نستخدم القانون وين يعني؟ نستخدمه على الداله هذه. we
لا
are trying، ولما نقول we are trying to find the critical value.
1
critical value شو
ماينس
تعريفه؟
اف اوف اكس
تعريفه
اوفر
ان هذا يساوي صفر، صحيح؟ صح؟ هذا معنى الكريتيكال
فيصير
فاليو ديريفيتيف
المقام
از ايكوال تو
صفر.
زيرو.
إيه.
يعني الان احنا نتعامل مع اي داله؟ نتعامل مع الداله الجديده هذه كوساين اكس ماينس 2 اكس ايكوال تو وات؟ زيرو. نعرف هذه نسميها جي اوف اكس، نسميها اتش اوف اكس، ونستخدم فيها النيوتن ميثود. يعني النيوتن ميثود راح تطبق على الداله هذه، مش الداله المعطاه في السؤال. واغلب الطلاب راح يطبق على الداله المعطاه في السؤال، ما يطلع اجابه صحيحه، اكيد ما تطلع اجابه صحيحه، لانه هو ما سال عن صفر الداله. He did not say we are approximating the zero of the function. He said we are approximating the critical number of the function. ايش معنى critical number? The derivative is equal to zero. So he is approximating the zero of the derivative function, not the function itself. وضحت الصوره هذه؟ Is it clear?
Yes.
Okay. Inshallah, I will
Yes.
solve a question about these two ideas in the review of this section for the final exam. I promise to do this, inshallah. نجي فقط الآن نعلق على قضية when do we need to stop. طيب أوجدنا x1، أوجدنا x2، x3، x4، x5 وهكذا. طيب what to stop؟ مو في النهاية أنت ما راح تحسب هذه الأشياء بيدك، يعني أنت you need to make a routine program by the computer by any language you like. راح تقول له والله evaluate x2 like this. Given x1, set x2 equal to this formula. If then you need to stop or continue. You need to give him you need to explain for the computer when to stop. طبعا دائما we need to stop depending on our accuracy we are shooting for. دائما في numerical method انت عندك هدف ان الايرور ما يتعدى مثلا 0.1 او ما يتعدى 0.01، يعني accurate to second digit، or ما يتعدى 0.01. I need to have more accuracy. طبعا more accuracy means more time, more iterations. صحيح؟ كيف نوقف طيب؟ where to stop؟ راح نلاحظها في السؤال هذا. السؤال هنا جميل، يقول using Newton's method to find 6th root of 2 correct to 8 decimal places. يعني يبغى الايرور يكون اقل من 10 to the power minus 8. Okay, how to do the exercise? First of all, I need to know how to define a function whose root is 6th root of 6. واحد يقول طيب الآن f of x 6th root of x أخليها x minus 6th root of 2. هذه الدالة الصفر حقها 6th root of 2. ما عملنا شيء. We didn't get any benefit here. How to define a polynomial function whose root is 6th root of 2? Okay, I can find it out by setting x equal to 6th root of 2. هذا الروت الحقيقي، هذا الريال روت الحقيقي الاكيوريت الريال 1. يعني بمعنى آخر I can take this one to the power 6 كأن هذا يحقق هذه المعادلة x to the 6 equal to 2. Or I can write this one as x to the 6 minus 2 equal to 0. إذا الآن أنا قربت الروت حق هذه x to the 6 minus 2 كأني أقرب ال 6th root of 2، لأنه هو الروت الحقيقي 6th root of 2. The real root, the accurate root is 6th root of 2. This is the exact root. If I can approximate the root of x to the 6 minus 2, it means I am approximating 6th root of 2. الآن نجي نقول والله f of x equal to what? Equal to x to the 6 minus 2. وبالتالي f prime of x ايش راح يساوي؟ راح يطلع عندي هنا 6x to the power what? To the power 5. Okay, جميل. Now he did not give us any guess، لكن أنا أعرف أن 6th root of 2 هو قطعا أكبر من الواحد وأقل من 2، صح لو لا؟ It's greater than 1 less than 2. لو جبنا هذا سؤال في كوز مستحيل طالبين يحلوا بنفس الإجابة. ليش؟ لأن everybody will guess his initial guess. واحد يقول والله باخذها 1.1، واحد ياخذها 1.23، واحد ياخذها 1.5. You need to take your initial guess. You need to take your initial guess. I will say okay, let x1 راح نبدأ بالواحد. Let x1 is equal to 1. تمام؟ أنا راح أعمل فقط الاتريشن الأولى، بعد كده I will copy them because we need a calculator. الآن x2 is equal to what? x2 by the formula is x1 minus f of x1 divided by f prime of x1. جميل. طيب نعوض شو يصير الناتج الآن؟ if I substitute x1 it will be 1 minus f of 1. f of 1 يطلع لي شنو 1 minus 2 minus 1 so this will be plus 1. f
Over
prime
6.
of 1 f prime of 1
6.
is equal to 6. يعني الجواب هنا تقريبا صار شنو 1 and 1 over 6 يعني 1 point. لما نقسم الآن 1 over 6 what do you have 1 over 6 يعني اقسم 1 على 6 طبعا point will be 10 10 over 6 will be 1 1 by 6 is 4 صحيح sorry 1 by 6 is 6 the remainder is 4 I have 40 divide by 6 is 6 by 6 this is 36 again I have 4 so it will be 1 this is 6 6 6 6 etc. صحيح I am dividing by I am dividing by 6 so this is what I have for the division 1 divided by 6. So I have 0.16666. So I need, he said 8 decimal places. So I will write up to 8 decimal places. Up to 8 decimal places. So I will write it here. 1.1 هذه واحدة 2 3 4 5 6 7. Then I will round it up to it will be what 7. يعني I will round up to the 8 decimal place. الآن السؤال want to stop. الجواب if you have 2 iterations in sequence agree in 8 decimal places بمعنى آخر إذا صار x2 minus x1 أقل من أو يساوي 10 to the power minus 8 stop. If not continue. والله صار x3 minus x2 less than 10 to the power minus 8 stop. Otherwise continue. فأنت راح تقول للكمبيوتر if xn plus 1 minus xn less than this number stop, terminate the routine. If not, then set xn plus 1 equal to this. وهكذا وكمل الين يوصل الى شنو الفرق يكون اقل. I did this I didn't do it actually. I copied them from the book. You need only a calculator to do this. So I will take this one and I will show you. Sorry. Let me copy them and paste them here and show you where to stop. طبعا now we need a calculator to substitute x2 x3 x4. لاحظوا الآن this is the calculations we need to make by the Newton method. لاحظوا مثلا جينا x2 هذا اللي أوجدناه احنا 1.666 قربناه إلى 7 آخر خانة. لاحظوا الآن x3 and x2 they agree up to what? Up to only what? The first one isn't it? فيقولوا هذه correct up to first decimal place. يعني بمعنى آخر the error will be less than 10 to the power minus 1 1 over 10. ما ينفع هو قال up to 8 decimal places فراح نحسب x3 راح ناخذ x3 أوجدناها الآن نجيب x4. طيب x4 and x3 after decimal they agree about the first one and the second one. بمعنى آخر x4 minus x3 less than 10 to the power minus 2. يعني this is accurate up to the second digit. Not enough. I need to find x5. راح نلاحظ ان they agree in the first one, the second one, the third one, the fourth one, but not the fifth one. So this is accurate up to 4 decimal places. Not enough. He said 8 decimal places. لكن if you find x6 راح تلاحظ ان they agree with the x5 and x6 they agree at the first, second, third, fourth, fifth, sixth, seventh, eighth decimal place. بمعنى آخر x6 minus x5 is less than 10 to the power minus 8. So you can see now we achieved our target accuracy by doing more iterations. This is called Newton method. Do you have any question about the last exercise? If you have any, please. Where to stop? We need to stop whenever we have the difference between two iterations in sequence less than the error we are shooting for. Is this idea clear for you? Okay, if it is clear,
Yes.
that is the end of the class, and that's the end of this section actually. Inshallah, tomorrow we will do the last section in this material, which is also a very simple section. Doesn't take more than 30 minutes. And that will be to conclude the material of Math 101. I will see you inshallah tomorrow. If you have no questions, if you have questions, you are
دكتور.
welcome to ask questions. Yes.
السؤال اللي زي كذا ما يطول